Today we are taking notes on day 11, which is full 3x3 systems. First, we're going to take a look at what we did before and what we're doing today. These first two examples, here you solved for y, which you then would use to solve for z, which you then would use to solve for x. The second example, you had an equation in terms of y and z. You then did elimination with the first and the third equations to make another equation in terms of y and z. Today, we're doing a full 3x3 system, which means 3 equations with 3 unknowns. We're going to do 2 examples together, and then you're going to do one on your own. Here's our first example. First thing that you want to do is determine which variable you would like to eliminate. I personally am going to eliminate the x's. To do that, I'm going to multiply my first equation by -2, so that I have -2x and +2x. First equation becomes -2x, subtract 4y, add 2z is equal to -4. Rewriting that second equation, now when I add, my x's are eliminated, and I have -2y, add 4z is equal to 8. Now I have one equation in terms of y and z. I need one more. In order to do that, I'm going to multiply my third equation by -2 this time. So again, I have -2x and +2x. Second equation stays the same again, so I'm just going to rewrite it. My third equation becomes -2x, add 2y, subtract 4z is equal to -10. When I add, my x's are eliminated again. And I have 4y subtract 2z is equal to 2. Now, these two equations have become a new system, so I'm going to rewrite them. I have -2y, add 4z is equal to 8, and 4y subtract 2z is equal to 2. Now, I need to do elimination again. I can eliminate the y's or the z's. I'm going to choose y. If you multiply the first equation by 2, we have -4y and +4y. My first equation becomes -4y, add 8z is equal to 16. Rewriting my second equation. Now when I add, my y's are eliminated, and I have 6z is equal to 18, which means z is equal to 3. I'm going to substitute this back into this first equation to find y. So I have -2y, add 4 multiplied by 3 is equal to 8. So -2y is equal to -4, so y is equal to 2. Last step is to find the value of x, which we are still missing. To do that, I'm going to substitute y and z into this very first equation of the system in order to find x. So I have x, add 2, multiplied by 2, subtract 3 is equal to 2. X add 1 is equal to 2, so x equals 1. Remember that we're not finished yet. We still need to write our solution as the ordered triple of x, comma, y, comma, z, which in this case is 1, comma, 2, comma, 3. Remember to check your answer. You can substitute that triple into all 3 of your original equations, and all 3 should be true. Now, we're going to do one more example together, and then you're going to do one on your own. Here's our next example. Again, we need to start by determining which variable we would like to eliminate. This time, I'm going to eliminate the y's. If I multiply my first equation by +2, I'll have -2y and +2y. First equation becomes -8x, subtract 2y, add 6z is equal to -18. Second equation stays the same, so I'm just going to rewrite that one. Now when I add, my y's are eliminated, and I have -5x, add 5z is equal to -15. Now I have one equation in terms of x and z. I need one more. In this case, I'm going to multiply this first equation, again, by +3, so that I have -3y and +3y. First equation becomes negative 12x, subtract 3y, add 9z equals negative 27. Rewrite that third equation, x, add 3y, subtract 5z is equal to 29. Now, when I add, my y's are eliminated again, as I did previously, and I have negative 11x, add 4z is equal to 2. Now, I have a system of two equations in two variables, so I'm going to rewrite those. Negative 5x, add 5z is equal to negative 15. Second equation is negative 11x, add 4z is equal to 2. Now I have two equations with two unknowns. I'm going to do elimination again. This time, I'm going to multiply my top equation by negative 4, my bottom equation by 5. So I have negative 20z and positive 20z. I end up with 20x, subtract 20z is equal to positive 60, and negative 55x, add 20z is equal to 10. When I add, my z's are eliminated this time, and I have negative 35x is equal to positive 70, so x equals negative 2. In order to find z, I'm going to substitute x into this equation in order to find z. So I have negative 5 multiplied by negative 2, add 5z is equal to negative 15. So 10 add 5z equals negative 15. 5z equals negative 25. Z equals negative 5. Now remember, our last step is to find y, which we are still missing. To do that, I'm going to substitute x and z into this first equation to find y. So I have negative 4 multiplied by negative 2. Subtract y, add 3z equals negative 9. 8 subtract y, subtract 15 equals negative 9. 8 and negative 15 is negative 7. When I add 7, I have negative y equals negative 2, which means y is equal to positive 2. Remember to write your solution as ordered triple again of x comma y comma z. In this case, our solution is negative 2 comma 2 comma negative 5. Remember to substitute this back in all three originals to make sure you have the correct answer. Now, we're going to do one on our own. If right now you could turn to page 27 in your packet, pause the video and try this one on your own. When you're finished, come back and we'll solve together. First thing that you need to do is determine which variable you would like to eliminate. I personally am going to eliminate the z's. If you chose x or y, totally fine, you should still end up with the same answer I do. I'm going to multiply my top equation by positive 2, so I have positive 2z and negative 2z. Top equation becomes 2x, subtract 2y, add 2z is equal to negative 4. Bottom equation stays the same. Okay, my z's are eliminated, and I have 3x, subtract 3y is equal to negative 3. I have one equation in terms of x and y, and I need one more. So I'm going to take my third equation, multiply this one by positive 2, so I have positive 2z and negative 2z. Second equation stays the same, so I'm just going to rewrite it. After I multiply my third equation by positive 2, I get 6x, add 2y, add 2z is equal to 16. Now when I add, my z's are eliminated again, and I have 7x, add y is equal to 17. Now, I have two equations with two unknowns, so this becomes our new system. We have 3x, subtract 3y is equal to negative 3, and 7x, add y is equal to 17. I need to do elimination again. I'm going to eliminate my y's by multiplying the bottom equation by positive 3. So I have negative 3y and positive 3y. First equation stays the same, so I'm just going to rewrite it. second equation becomes 21x, add 3y is equal to 51. When I add, my y's are eliminated, and I have 24x is equal to 48. So x equals positive 2. Now, I'm going to substitute this back into this equation here in order to find y. I end up with negative 3y is equal to negative 9, so y equals positive 3. Last step, I need to determine the value of z. I'm going to substitute into this first equation of the system to find z. So I have 2 subtract 3 add z equals negative 2. Negative 1 add z is equal to negative 2. So z equals negative 1. Last step, remember to write your solution as ordered triple x comma y comma z. So 2, 3, negative 1.